Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on graph theory, lecture number 34, in which I will discuss some theorems on Cut-Vertex, EdgeConnectivity and VertexConnectivity. Now we prove a theorem. Theorem is a vertex V is a cut-vertex of a connected graph G if and only if there exists two vertices x and y distinct from V such that every path between x and y passes through vertex V. Now we prove this. Let G be a connected graph and V is a cut vertex of this graph G. Therefore, by removing the vertex V from G, the remaining graph becomes disconnected. Let x and y be vertices on components G1 and G2 respectively. Since G1 and G2 are components of the graph, G, therefore there exists no path from vertex x belongs to G1 to vertex y belongs to G2. But if the vertex V is included with G minus V, then the graph G becomes connected and we get every path from x to y via V, vertex V. Conversely, let G be a connected graph and x, y be two vertices of the graph G such that every path from the vertex x to vertex y passes through a vertex V. Therefore, if the vertex V is removed from graph G, we do not get any path from a vertex x to vertex y. Therefore, G minus V is a disconnected graph. Therefore, the vertex V is a cut vertex. Proved. Now we prove the next theorem. Prove that the edge connectivity of a graph G cannot exceed the degree of the vertex with smallest degree in graph G. Let G be a connected graph and V be a vertex of smallest degree in G. The degree of V, vertex V, is denoted by dV. Therefore, at most dV number of edges are incident on vertex V. If these edges are removed, then the vertex V is disconnected from other parts of graph. Therefore, the graph becomes disconnected since edge connectivity of a graph is the number of edges in the smallest cut set. That is, by removing minimum number of edges from the graph, to make the graph disconnected, since V be the vertex of smallest degree in graph G, and it has been disconnected from graph by removing at most dv number of edges, that is edge connectivity less than equal to dv. Therefore, the edge connectivity of a graph G cannot exceed the degree of the vertex with smallest degree in graph G. Proved. Now we prove the next theorem. Next theorem is the vertex connectivity of any graph G is always less than or equal to edge connectivity of graph G. Now we prove this. Let G be a connected graph and let P equal to edge connectivity of graph G. Therefore, there exists a smallest cut set S which contains P number of edges. When edges of S are removed from graph G, the remaining part G minus S is a disconnected graph. Let G minus S partitions the vertices into two disjoint sets, capital V1 and capital V2. Since edges of S connect some vertices of vertex set V1 to some vertices of vertex set V2. So, by removing at most P vertices from capital V1 or capital V2 which are incident on edges of S, the edges S are removed. P be the number of vertices from either vertex set V1 or vertex set V2, that is from graph G. So, by removing at most P particular vertices from G, the edges of S are removed. Therefore, this denotes the vertex connectivity. Therefore, vertex connectivity less than equal to these edges of S are removed. This denotes edge connectivity. That is, vertex connectivity is always less than or equal to edge connectivity. Proved. Now we solved a problem. Problem is every cut set in a non-separable graph with more than two vertices contains at least two edges. Let G be a connected non-separable graph with more than two vertices. We know that a graph is non-separable if vertex connectivity is greater than 1. Therefore, vertex connectivity of G is greater than equal to 2. This is number 1. Since we know that vertex connectivity is less than equal to edge connectivity, This is number 2. From 1 and 2, we get edge connectivity is greater than equal to 2. This is number 3. Since we know that number of edges in the smallest cut set of graph G is the edge connectivity of G. Therefore, from 3 and 4, we get number of edges in the smallest cut set is greater than equal to 2. Therefore, every cut set in a non-separable graph with more than 2 vertices contains at least 2 edges. This is from 5. Proved. Now we prove the next theorem. The maximum vertex connectivity of a connected graph with n vertices and e edges is the integral part of the number 2e by n. Now we prove this. Let G be a connected graph in which n equal to number of vertices, e equal to number of edges. Therefore, total degree of all vertices equal to, since one edge give rise to degree to the graph, therefore e number of edges give rise to e degrees of the vertices. This is equal to 2e. Therefore, we get at least one vertex of graph G whose degree is less than or equal to 2e by n. Let that vertex equal to V. We know that edge connectivity is less than equal to degree of V, implies that edge connectivity is less than equal to 2e by n. Let this is number 1. Also we know that vertex connectivity is less than equal to edge connectivity. This is number 2. From 1 and 2 we get vertex connectivity is less than equal to 2e by n. This is number 3. Since vertex connectivity is an integer, therefore we may take value of the integral part of right side of 3, which is denoted by under bracket 2e by n. Therefore, from 3 and 4 we get vertex connectivity is less than equal to integral part of 2e by n. Proof. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.